Hi everybody, it's Jordan here. Welcome back to my RStudio mini-series. If you've been following in the previous sessions, previous two videos, we worked on installing R in RStudio and changing some settings in RStudio to make the experience working in RStudio a bit more user-friendly. We haven't done too much coding yet, and today that's about to change. But we're going to do some pretty simple code which allows us to understand the data frames available to us a bit better, and also calculate some summary statistics for numerical columns in data frames. Prior to doing that, I said last time that you want to check for any package updates in RStudio that have happened since you've been in RStudio last. That's important to do because you want to stay up to date with any changes made by developers. Since the last time I was in RStudio, these packages have updated. So you just click Packages Update, and let's get these updates. Select all, Install Updates. I've got a lot of packages, so it's inevitable that some packages are going to update in between use. That's just showing some update progress in the console. Everything seems to be unpacking successfully, which is great. Right, I'm going to start a new script here. I'll call this like video free. And remember to leave hashtag notes to yourself, which are useful for you to keep on top of your own project, and will also be useful if you send your scripts to anybody else, okay, for them to do the same thing. Let's call this one Data Frames and Summarizing Data. Right, so that was just a script that I opened, a new script, by clicking File, New File, R script. We're going to check our working directory. Okay, yep, I'm in the right place, and I'm going to save this at this point. And at this point, I'm just going to save the script and give it a name that makes sense. It will be saved into the working directory that you've set based on the information we learned last time. Alright, okay, so I'll just call this one like freebie data frames. I already started on a script before, but that was just to get preparation for this video. Freebie data frames. Okay. Libraries. You always want to have tidyverse running at the beginning of your session. It's just so useful to have tidyverse running. You're probably going to need it for any cleaning or any plotting that you want to do in your project. When you start RStudio, tidyverse doesn't start by default, so you need to use either the library code or turn it on in your list. Okay. Tidyverse also contains some very useful data frames that we will continue to work with in the future. For now, we will view a data frame. You don't need tidyverse to view because it's already in R, but this is one that people really use often to learn R and R coding. This is a data frame on plants called iris. There's 3 species of plants, which are setosa, versicolor, and virginica. The measurements here in the first 4 columns are length and width of their petals and the sepals of different individuals that belong to these 3 plants. Now note that for any summarizing or modeling or graphing, we need all the information that we're going to include to be in the form of columns. One important column is missing from this data frame, which is the individual numbers. It just so happens that these individuals, these repeats of setosa, versicolor, and virginica, can be got at or can be learned from the row numbers, but we want to have those individual identifiers in a column. So let's do that first. That will really make our life easier working with Iris, because otherwise we're just left with multiple individuals of Setosa. We don't know which one's which. So this is the first code, the first real line of code that we're going to use. Okay, so we're going to make a column with plant IDs. Okay. In the process of coding specific lines, we'll learn a lot of important stuff about syntax and symbols. So what I'll do first is I'm going to copy the iris data frame. Okay, and I'm going to call it iris2. Let's just look at that line to start off with. We're creating a new data frame here, which is called iris2. That goes on the left side of this symbol here, which is the back arrow. And this is going to be based on the original data frame called iris. I see some people online make changes to data frames without creating copies first, and I don't really recommend that. We're only creating a column here, so it's probably not the end of the world if we were to overwrite iris. Of course it's not, don't worry, it's not going to overwrite anything like for anybody else in the world. It's just for you right now in your session. But later on we will do more complex manipulations where we delete rows, where we subset columns and only show certain columns. So we're making big changes to data frames, mostly in terms of removal at a later point. And you wouldn't really want to overwrite iris because you might not like something or want to change something you did, in which case you want to go back to the original iris to undo something. So when I'm making big changes, I copy things. Okay. And the back arrow always points to the thing that you're creating, and on the right side is what is being created from. Okay. So yeah, firstly, leave a hashtag here. You can put hashtags throughout the entire script, but you should do that at each line in my recommendation. Copy the df, the data frame. In this next line of code, we are going to say iris2 $, and then in quotation marks, we are going to write individual. So this means that the $sign refers to a column. Okay, and this word in green is the column name that we are creating. So we're creating individual column in iris2. Okay, back arrow again. Some people use equals sign instead of the back arrow, but back arrow is used more commonly. Okay, and here it's going to be SEQ. So when I start typing SEQ, this starts to suggest code that we might want to include. What we're trying to do now is we're trying to assign the row identifiers to a column, and this is how to do it. SEQ underscore LEN. Okay, then obviously a forward bracket, n row bracket iris2. So a couple of things here. Obviously we're just saying that we're assigning row numbers from 1 to the final row in the iris2 data frame. That's what the n row is meaning. And this is the reason why I use rainbow colored brackets. In the settings, we saw that last time. The reason why is because we now have multiple pairs of brackets within this code. Okay, because the iris2, the name of the data frame, is in orange brackets, and the first bracket and the last bracket, those are the closing ones, and those are always going to be in pink. So if we didn't have a pink bracket at the end, then we know that something's wrong with the code, and if we try to run it, it'll give us an error message. So that's why I like to colour them. We're always looking in this colour scheme anyway to finish on a pink bracket. Okay. So that worked, and we know it worked because we have this triangle appearing in the console and no error message and no warning message. So that's a success. now what we're going to do is we're going to use the view function. View with a capital V, small v doesn't work. Iris2. This data frame that we've created with this new column can be viewed like this. We have all 4 columns that we saw before, but we have this new column now where the row numbers, the individual numbers, have been added as a column to the data frame. That will make this data frame much easier to work with for calculating averages, for seeing which actual individuals were different than the other ones, etc, etc. Let's try and focus on each individual by itself because we can see that they do have differences in their measurements. Just so you know, the point of this data frame is that there's, amongst these 3 species of plants, there's one, I won't ruin it, I won't spoil anything, there's one that's much smaller and there's one that's much bigger, and one that's in the middle. Okay, now this is a good opportunity to talk about data types. Okay, data types. So what do I mean by data types? Obviously, Iris2 contains some numerical columns, and then there's one column that contains words. We get information about that by using the str function. Okay, str iris2. You run this into the console, and here we see some output. It says sepal length, sepal width, all of these column names with a $sign in front. Every time you see the $sign refers to a column name. Then we've got, well, firstly we have this information that we also saw at the bottom of the data, 150 observations, okay, that's 150 rows, and 6 variables. Here it says 6 total columns. That's just information about, you know, the data there. Variables, the word variables and the word columns are used interchangeably by coders. Here we have the abbreviation num factor int. And what does that mean? So this describes the type of data in each column, which is important to know because we can do different things with different types of data. We'll also have limitations based on the types of data. Num means numeric, and int is also numbers. The difference is num are decimal numbers, and int are integer numbers. int means integer. We also have this column species, which says factor, and factor generally words, or the column contains words, or some sort of groups. You might also see CHR, which means character. So factors and factor columns and character columns generally contain text. So feel free to ask any questions in the comments below. I also thought I might start like a Twitch channel or something and do live streaming, which would allow more interaction where people can ask questions about R and RStudio and data frames as we go through them. Okay, so we know that we have numerical columns in the Iris2 data frame, and let's use some basic code to get summary statistics for those numbers. Summary statistics for numerical data. Okay, so this is very simple as well. This is just summary, Iris2. You run that into the console, and we have, okay, I don't always remember to move my little video, so sometimes it can get in the way of code. But that's been moved out of the way now. Okay, these columns are listed here. The most relevant columns for this are sepal length, sepal width, petal length, and petal width. Obviously, we see that integer, or the individual column that we assigned ourselves are given integers, but that's just how we've done it here. You could have also used like A, B, C, D for the individual identifiers. So kind of ignore this column for now. These are the numbers, the decimal numbers that we're interested in. And we have lots of important summary stats about these columns. Like for example, mean, median, min, max. Let's look at the petal length column. So the min for the petal length across all the individuals and all the plants is 1. And I think that's in centimeters, although I always forget whether it's millimeters or centimeters with iris. Just so you know, it should really be written in the column headings, just to say that. Especially for any projects you guys are working on, units should be in the column headings. Alright, and the max for the petal length is 6.9. So quite a big difference between individuals and plants here. And this is very much an overview, like I said, across all individuals and plants. So it would be more useful to kind of get means and summary statistics for each species, and we'll do that next time using tidyverse, where we're going to group by species. So this data frame here is 150 rows and 6 columns. Okay, it could be the case that we want to reorder or reshape this data frame so that maybe the different measurements, the measurement names, sepal length, sepal width, petal length and petal width, are listed in a row. That would create what we call a long data frame, okay, even longer than it is right now. So that would create like a list data frame, maybe just think of list. And we want to learn that because certain analysis, certain things you can do in RStudio benefit from data being organized in a long format or a wide format. Let's have a quick look then at some important code which exists in tidyverse called the pipe function. And I kind of wanted to get this out of the way ASAP because the pipe function is the most important syntax symbol that you can learn in RStudio. This symbol, okay, pipe function, looks like this. Percentage, forward triangle, percentage. And it's used for so much cleaning, manipulation, organization, and loads of things you can do. So for example, we'll use it later to create columns that depend on other columns, for filtering data, for removing columns. That's the pipe function. Okay, let's do a new data frame. We're going to name this data frame iris long. Iris long. Okay, then the back arrow again. So we're creating iris long from iris 2. Here comes the first use of the pipe function. If you type that in there, okay, then push return, that put us onto the next line, and we have this little like indentation at the beginning, and you want to keep that. Pivot underscore longer. Okay. This might seem a bit complex already for like the third session, but this line is so useful. And once you have the script, which I'll put on Figshare, you can just copy and paste it for future data sets where you might want to do something like this. Okay, you're going to have a names underscore 2. Right, we're going to create columns again, and so we're creating columns, and you know that because we're typing into green speech marks. Okay, just write names here. You can call them whatever you like, but we'll call it names. Then values underscore 2 equals. See, note here that it doesn't really matter if you've got spaces before or after an equal sign, for example. and we'll call this one values. Okay, actually let's change this names one to measurements, so it'll make more sense in a second. Right, run this. Yeah, of course. So here you're going to add something at the very beginning, which is your numerical columns in the data frame. Calls equals 1, 2, 4. Okay, the ones with the decimals that we're interested in for the summary statistics. So you're going to add that first, and then run it, and it worked. Now, if we view brackets iris underscore long, we will see that iris data frame being presented in a different way. So this has created a list now, and depending on what you need to do in your project, this can be a useful step. So in this case, we have a list of individuals, 1, 2, 3, 4, 5, okay, and all their measurements for each one listed on top or stacked on top of each other. Try in a future session to plot different kinds of data sets, data frames, wide format, long format, and you'll be able to do different kinds of things. But we're not really going to talk too much more about that for now. For now, I think I'll go back to, well, I'll leave a note here, to create a data list, okay, which is brackets long format. I think what we'll do at this point is we will use the pairs function to get early visualizations, first visualizations of the data. And I don't know about you guys, but I'm a visual learner, and I really like to make plots as soon as possible to figure out what the relationships are between columns. That will very much help you to decide what to do next, and it might even help you come up with questions. Quite a lot of the time, people that I teach in that I help on assignments at university, they are given flexibility to ask their own questions based on data, and it's like, okay, you're allowed to investigate any question you like, come up with it, you know, give your reasons for that question. This can be very, very useful for that. Okay, so if we just do pairs brackets iris 2, so we'll go back to this one here where we calculated the summaries. Alright, now we've got this appearing in the plots tab. Okay, so that's the plots tab down at the bottom. You need to remember to move this up and down, you know, in order to make it bigger for your own needs. Okay, of course, if your console disappears, it hasn't disappeared. You're just going to use these buttons to minimize and maximize. I can do something slightly nicer to this graph right now, okay, by typing in upper.panel equals null. Okay, in this version of the plot right now, it's difficult to see, but everything on this side is actually a mirror image of everything on this side. So we're going to get rid of that mirror image just by typing upper panel equals null, and then we'll talk more about what it shows. So that's updated now. What we're seeing now is a bunch of different plots for the numerical variables. Ignore the species column. Okay, these are actually being assigned to 1, 2, and 3, but ignore that for now, and ignore the individual column. So what we're really looking at is this stuff here, okay, between sepal length and petal width. This graph here, okay, is the sepal length being plotted against petal width from the data. This one here in the corner of the words sepal length and petal length is the relationship between sepal length and petal length. And in that case, sepal length is on the y-axis and petal length is on the x-axis, so you just need to remember that. We're already seeing quite a few linear relationships. Okay, so for example, when sepal length goes up, petal length goes up. Like I said, that will help you to come up with questions for a project. Also seems that there's some sort of groups going on here. Okay, grouping, like for example, there's a bunch of points down here. You know, that might be one species, for example, and we could look at that further. Same as going on over here. So it really helps you to come up with questions. There's another way to look at this, which is through correlations. So I'm going to use a library, okay, that you might not have, which is called corplot. Okay, so it's corrplot. All right, so you just need to install that first and then load it with that method there. Then in this point here, we can, oh, my mouse got stuck. That's it. I'm just going to create a new object here, which is called analysis, back arrow, COR, just COR, and then iris 2. This doesn't work for this data frame so far because there is a non-numerical column. What we can do is we can just put square brackets here to say the numerical columns that to specify only numerical columns. Okay, so that's 1 to 4, and then run it, and then it will work. Okay, now if we do the word corplot analysis in brackets, nice, we get this kind of nice bubble plot which shows relationships between columns again, so a different way of looking at the data than the pairs. And ignore the dark blue circles in the middle because that's pairing against itself, so that doesn't mean anything. But like here, for example, this one here, okay, this is a light blue color. This is a relationship between petal width and sepal length. If you have a blue circle, that's a positive relationship, and if you have a red circle, that's a negative relationship. The stronger the color means stronger relationship in that given direction. So I think I'll leave it there. Very good for exploratory analysis, for figuring out what to do next. I hope you enjoyed this. Please leave your comments below. And I also thought maybe I could make a Twitch account. I'm not sure if I'm going to do that, but then it could be a good way to have more interaction with people watching, because it seems like I've been told some people would really benefit from this, or are benefiting from this video series. Twitch or some sort of live streaming could make that even easier and more beneficial for everybody. Next time we will look more at things you can do in tidyverse, such as ggplot2 and more of the pipe function. I will put the script from this onto Figshare, and I look forward to catching you in the next video. Also, feel free to visit my site, jordycoding.com, if you need any specific help with specific projects. If you aren't too interested in learning R, but you still want help with projects, I also offer consultation. So that's great, but I really recommend learning R in RStudio because it'll make your data analysis abilities much stronger and save so much time over other software. Have a good day, guys.